Looking at exercise 3.5, absolute value equations and inequations. Now, we're going to be solving a number of equations, just looking at how to sketch in absolute values first. If I've got, for example, the absolute value of x equals a, it means that x equals either positive a or negative a, equals plus or minus a. For example, if a was 2, if x was, say, 2, a would be 2, but if x was, say, negative 2, a would be 2. Remember that absolute value of a means, absolute value of x equals a means that if I were to plot this on the number line, see it means that x could lie a units from the origin on either side. Absolute value means distance of x from the origin. So the distance of x from the origin is a units, but it could be a units to the left, a units to the right, okay? This one here, absolute value, I'm going to write that in a minute, all right? I'll just put it here, that x is a units from the origin. The distance of x from the origin. Always absolute value is defined as distance from the origin. So I'm just going to put absolute value of x is the distance of x from the origin. You have to remember it like that. If you remember it like that, it really helps you when you come to set up more difficult problems. All right? Absolute value of x is the distance of x from the origin. If the absolute value of x is a, then x is a units from the origin. All right? Could be from the left or on the right. That means that x could be positive a or negative a. It could be on the left of the origin or the right of the origin. If the absolute value of x is less than a, it means that x lies within a units from the origin. Means that, what it means that is that x lies from a to negative a, or x is within a units from the origin, or x lies within a units from the origin. Absolute value of x is less than a means that x lies within a units from the origin. In other words, x lies, let's say a was 2, x is between negative 2 and positive 2, right? If the absolute value of x is greater than a, that means that x is more than a units from the origin. So it means that, well, if I draw a number line, see what I'm going to do here, I'm going to draw it on a number line. Negative a, x lies between those two. With x is less than, sorry, I need to make this bigger. And I should have spaced this out a bit more. If this is the origin, back over these again, absolute value of x equals a, as we said, x is a units from the origin, so it could be a positive a or negative a. If absolute value of x is less than a, x lies within a units from the origin or of the origin, so x is anywhere between negative a and positive a, here is the origin, okay? If absolute value of x is greater than a, then a lies not within a units but beyond a units from the origin. Means that here x goes this way or x goes that way. It's more than a units from the origin. It means that x is greater than a and or x is less than negative a. So when you see it, so x lies more than a units from the origin, or we could say the distance of x from the origin. So it means that x lies more than a units from the origin, or the distance of x from the origin is greater than a units. Let's just plot these. So the absolute value of x equals 3. X lies 3 units from the origin. So remember, x equals plus or minus 3. So to plot that, you'd have -3 and 3. I'll put a 0 in the middle, okay? Plotting absolute value of x is less than 2. The distance of x from the origin is less than 2 units. That means that x lies between -2 and +2, but not including them. Are we okay? Absolute value of x is greater than or equal to 1 means that x lies either 1 unit or more than the distance of x from the origin is greater than or equal to. Actually, whenever you see absolute value of x, you say the distance of x from the origin, and then we say is greater than or equal to 1. So here, the distance of x from the origin. So every time you see absolute value of x, you say the distance of x from the origin is greater than or equal to 1 unit. All right? So it could be on either side. So what I'm going to do, so when you see that, that means you say to yourself the distance of x from the origin is. When you see that, the distance of x from the origin is greater than or equal to 1 unit. You have to colour these ones in going that way. So I'm going to go say ... Okay? When you see that. Just looking, you know, if absolute value of x was 7, don't we say x equals 7 or -7? So I've got absolute value of x plus 2 is 7. If you just look at it in a common sense approach, this x plus 2 couldn't it equal +7, or couldn't the x plus 2 equal -7? Because absolute value of -7 is 7. So from there we set up two equations, that x plus 2 equals 7 or x plus 2 equals -7. We okay with that? So now this time the distance of x plus 2 from the origin is 7 units. Not the distance just of x, it's the distance of x plus 2 from the origin is 7 units. So, or you can think of it as the absolute value of 7 is 7, but the absolute value of -7. What is contained within the absolute value sign could be 7 or -7. Because isn't the absolute value of -7 7? Remembering back to chapter 1, all right? So then we just solve these two. So x is 5 or x is -9. So there are two solutions there. Okay. Another question. I'm going to do question D. The absolute value of x minus 5 is less than or equal to 1. Now, normally we would say the distance of x from the origin is, but no, we've got to say now the distance of x minus 5 to the origin is less than 1 unit. So, looking back here, we said x lies between -a and +a, right? But this time, x minus 5 lies between -1 and +1. X minus 5 lies within 1 unit of the origin. So we set up -1 is less than or equal to x minus 5 is less than or equal to +1. The distance of x minus 5 from the origin is less than 1 unit. That's why the definition of absolute value is so important. You don't just do what you did up here, do one positive, one negative with inequalities. It doesn't work like that. So when you've got x plus 2 equals 7, yes, you do, the x plus 2 could be +7 or it could be -7. But when it's inequalities, you have to think distance of this from the origin is greater than 1 or less than 1 or less than or equal to 1, etc. So now we just solve it like we did in the last exercise. What do? plus 5 plus 5 plus 5. Negative 1 plus 5 is 4, is less than or equal to x, which is less than or equal to 6. In other words, x lies between 4 and 6. Okay? 2h. Remembering with the definition, what does it mean? The distance of this 2x minus 3 is more than, greater than or equal to 15 units from the origin. How are you going to be more than 15 units from the origin? You're either going to be that way or you're going to be this way and coloured in. But that is where 2x minus 3 is, not the whole solution. So how do I set up that 2x minus 3 has to lie down here? What do I write there? Is less than or equal to negative 15, or 2x minus 3 is greater than or equal to 15. So just writing above here, 2x minus 3 is greater than or equal to 15 units from the origin. Lies or whatever. Does that make sense? Whatever's in the absolute value sign is more than 15 units or equal to 15 units from the origin. Greater than or equal to 15 units. So now we solve these two inequalities. So isn't it plus 3? Negative 15 plus 3. Please write it out because, like I said, this is where people make the mistakes. They'll write negative 18 instead of negative 12. Minus 1 mark. Right? So negative 15 plus 3. I know it's extra working, but we're just dividing by positive 2, not by negative 2. So x is less than or equal to negative 6. And our other solution, 2x is greater than or equal to 15 plus 3. 2x is greater than or equal to 18. X is greater than or equal to 9. That is not my solution up the top that I sketched. That is just helping me understand how to write these two equations out. Okay? So my solution, if I do want to sketch that on the number line, x is less than or equal to negative 6. X is greater than or equal to 9. Please, you do not need to write every single other number in between. If you want to, you could roughly put where 0 is. So let's try some solutions and see if this is indeed true. Let's try x is 10. That would be 20, take away 3. Absolute value of 17. That's 17, yes, that's greater than or equal to 15. Let's try something less than negative 6. Let's try negative 7. Negative 14, take away 3. Negative 17. Absolute value of negative 17 is 17. And 17 is greater than or equal to 15. So that looks good. And I had, in an earlier equation here, we said what's in here could equal 7 or negative 7, yes? Same thing here. What is in the absolute value sign could equal 5x plus 4 or negative bracket, or the negative of that 5x plus 4. Okay, so that's how we're going to set it up. So we've got 4x plus 3 could actually just equal 5x minus 4, or 4x plus 3 could equal the negative of that. Because when you take the absolute value of that negative, you end up with the positive answer. Okay? So now we're solving these two equations. So 4x minus 5x equals negative 4 minus 3. Negative x equals negative 7, so x is 7. Or 4x plus 3 equals negative 5x plus 4. 9x equals 1. X is 1/9. Look, you'll need to check your solution, but when you've got the one absolute value sign and this other just ordinary equation or expression, it will always work. It's only when you've got two absolute value signs that we need to check. Oh, no, sorry, no, wrong way round. You always need to check. You always need to check. I put here, sorry, always check your solutions, because one of them may not work. And often one of them does not, actually. All right, so x is 7. Let's try. and substitute it into the original expression, not into what you've written, into the original expression. So when x is 7, what do we get? 4 times 7, I've got 28, absolute value of 28 plus 3 equals 5 times 7 minus 4. What have I got? Absolute value of 31 equals 31. That's good. So x equals 7 is a solution. That's good. And trying x is 1/9. Absolute value of 4 times 1/9 plus 3 equals 5 times 1/9 minus 4. What's that? 4/9 plus 3. That's 3 and 4/9. Absolute value of that, it's positive, equals 5/9 minus 4. Tell me what that is. Negative. Is that negative 3 and 4/9? Does that equal that? So x equals 1/9 is not a solution. Sorry, it's in these ones with one absolute value sign. Often one of them will not be a solution. So even though I'm taking absolute value of this side, I get positive 3 and 4/9, but this side has no absolute value sign. Remember, I'm putting it into the original question, not into this. All right? So x equals 1/9 is not a solution. So your solution here is x equals 7 only. If you just did this and didn't show the other side, you're not going to get full marks. Okay, you need to show that x equals 1/9 is not a solution. So this is still looking at the scenario with one absolute value sign. You try this one on your own. So what's in the absolute value could equal the 3 minus t, or what is in the absolute value sign could equal the negative of that. So just look up when you're done. And we need both solutions checked. Absolute value of 2 times t over 3 minus 7. 20 over 3, that's 6 2/3. Take away 7, that's the absolute value of negative 1/3. 3 minus 3 1/3 is negative 1/3. Absolute value of negative 1/3 is a positive third. That does not equal negative third. That is not a solution. So t equals 2 over 3 is not a solution. And right hand side, absolute value of 2 times 4 minus 7 equals 3 minus 4. That's 8. Absolute value of 8 minus 7, that's absolute value of 1. So 1 equals negative 1, that is also doesn't. So therefore t equals 4 is not a solution. Now, I want to show you why. Remember I was doing critical points before? Remember 2 weeks ago we looked at critical points when we were doing absolute values? So neither of these is a solution. So there's no solution to this one. Actually, when we do learn to graph these, and we will in chapter 5, these obviously never intersect. These two may never intersect. That's why there is no solution. In the last question, we were trying to solve the following absolute value of, it was 2t minus 7, but because I've got x and y axes, I'm just going absolute value of 2x minus 7. If I'm trying to solve equals 3 minus x, right? That's what I was trying to solve this one. Absolute value of, it was 2t minus 7 equals 3 minus t, but I put y and x. I put x so that I can graph it, okay? When you want to find the solution of that, it's like you're trying to solve two equations simultaneously. You can graph y equals 2x minus 7, the absolute value of that, which is the red graph. you can graph the line y equals 3 minus x. If I look at that now, can you see that there's no point of intersection between them? That's why we had no solution, okay? So if you want to look back at your sheet, let's look at one other where there was a solution, for example. So for example, I'll put in another one where there was a solution. So this is why that question 3J, there was no solution. See how these two lines or functions do not overlap, okay? Question we were trying to solve in one of those, sorry, I think it was 4x plus 3. In question 3F, we were trying to solve this equation, absolute value of 4x plus 3 equals 5x minus 4. What you could do to solve it is sketch y equals the absolute value of 4x plus 3. That's the red curve, right? And you could sketch the blue line, which is a straight line positive gradient cutting at -4, y equals 5x minus 4. Blue line. Notice those two graphs intersect here when x is 7, which was why we did have two solutions for question 3F. That was x is 7 and x is 1/9. Obviously, x is 1/9 was not a solution. We didn't get a solution for that, but we did get that x is 7 was a solution. The reason it's solution is because that's where the two graphs intersect each other. All right? Do you get the idea now why sometimes we'll get one solution only, no solutions if the two graphs do not cut, and yeah, two solutions would be if the graphs cut each other twice. Okay?